everyone. In this video, I am going to do a image segmentation task using the deep learning tool in Dragonfly version 2022.1. I have already loaded my data. The data I use here is a subsection of mouse retina, broad internal segments imaged by FIBSIM on SACE Crossbeam 540. Data courtesy of Christopher Black and Electron Microscopy Core Facility and NHLBI/NIH. Also, please see the description below for more details about the data. Okay. In this image segmentation task, what we are going to do is we are going to classify pixels that belong to mitochondria from the neighboring tissue. Let me hide this as I don't need it anymore. Okay, before opening the deep learning tool, first I'm going to prepare my training data. So for that, three things I should do beforehand. First, I have my training input. In my case, it's the mouse retina data. It's my training input. This mouse retina data has total 450 slices. I'm not going to use all the entire 450 slices, out of which I'm going to use only 5 slices for training. Slice number 10 and then 100th slice and every 100th slice after, and hence I have only painted those 5 slices. You can see this. Let's go to slice number 10 and see this. Here it's my 10th slice, and if you see my 100th slice, I have painted that. And if you go to 200th slice, you see, and again 300, you will see I have painted that, and then the one final slice number 400. Here I have painted the mitochondria for 5 slices. One most important thing here is that my training output should be in the form of dense multi-ROI, which means like my every pixel must be labeled as one of the classes. In my case, each pixel must be either a mitochondria or a background pixel, as it is a 2-class problem. Here it's not dense multi-ROI, it's ROI in my case. So what I have to do is I have to create a dense multi-ROI from ROI. So if you right click on that a menu item called a create dense multi-ROI from, just click on that. This will create a multi-ROI from 2 ROI. So you see 2 options, class and scalar information. So it's mitochondria and its complement data. So total number of mitochondria pixels and it's the background pixels here. So those information are here. So this is our, we can rename this if you want as training output, but please make sure it must be a multi-ROI. Okay, so you can just give a name, it's a training output. And then since I'm not going to use the entire 450 slices for training, I have to define a training area. Normally the training area is a few selected slices from the image stack, and it may be the complete portion of the selected slice, or it may like a part of the, it may or may not be the complete portion of each selected slice. Okay, in order to define the training area, I need to have a mask. So first let me go ahead and create a mask. Again, go to segment tab, under ROI tools, click on new. Just give a name as mask, and then just as a color that you prefer, and then it's the same geometry as training output or the data, and then click OK. Okay, so now we are in 400th slice, and again use the ROI painted tool, rectangle, under 2D view tools. use the rectangle tool to paint the entire slice. Now we are in slice number 400. I'm going to paint this and then go to slice 300, apply, close. Make sure you hold down the control key and then go to slice number 200 and then slice number 100 and then hold down the control key and go to slice 10, the final slice, and then make sure hold down the control key and then paint. Okay, that's it. So we defined our training area. Here we have three things now: mask, our training output, and training input. Okay, you can just mouse retina and you can just name this as training inputs if you want. Okay. And then what we could do is go to, now we are ready to use our deep trainer tool. So go to artificial intelligence, you will see deep learning tool. Go to deep learning tool. As you see here, we don't have any models already generated. What I'm going to do is I'm going to generate a new model. So click on this new button. A model generator window will pop up. On the architecture, you will see list of architectures. I'm going to use today the unit architecture, and then architecture description. It just tells you like a very short note about the architecture. Here model type, and then it depends like what on the application. So here we are going to do semantic segmentation. So model type is semantic segmentation, and class count, it's like a number of classes we have. One is mitochondria and the other one is the other complement pixels like background. So number of class is 2 since it's a binary segmentation. And input count, we are using only in one input, so just one. Input dimension, so here 3D is not enabled because we are not going to use 3D convolution, so this is not enabled here. You could go with either 2D or 2.5D. So 2.5D dimensions, in the sense we are configuring multi slices here. Like if you enable this, can give the number of slices. So based on that, the input dimension configure multiple slices. So here in this demo, I'm going to use input as just a 2D patch. And then the name here, you can just give mitochondria segmentation. And description, you can just write a note here. So another important parameter here is depth level. So depth level in the sense like number of pooling layers in the unit architecture. It's basically the depth of the unit architecture. It's default, it's 5, so I'm going to keep that as a default. And initial filter count is like a number of filters we use in the first convolution layer. So you can adjust this number of filters. I'm going to use 64 filters. Okay, and then just generate. Okay, model generated. Model unit mitochondria segmentation was generated successfully. So click OK, and you can now close this panel. Then we are in a deep learning tool panel. Here what you see is model name. Model name is just the architecture name along with the name that you specify. And model type, it says the number like a type of segmentation. And then what we do is like a number of class counts. And the model status, it says not trained. So because we have just generated the model and we not yet trained. And then parameters count, it's like the number of parameters involved in the network, and the date is timestamp. And again here you see the details of the architecture, you can go through it. And for classes, what we see, it's another important feature here. So let's say if you have some imbalance in your class, like let's say your background pixels are more and your foreground pixels are very less, you can just adjust the class weights here according to your problem. Okay, so you have three options here to choose the class weights: uniform, computed from labeling, or custom. So custom means you can just define that. So what I'm going to define the weights, you can hear what I'm going to do for this demo. I'm going to use a uniform class weight. Okay, so you can just play with that. So that's it about like in the beginning, and then we are ready to go to training. Now go to training. This is the place where you feed the input. Okay, so input, what we are going to is our training input. It's our mouse retina training input, and output is our multi ROI. But most important thing here is we are not going to train all the 450 slices, so we are restricting to only 5 slices for training. So it's important to define the training area. So the mask is the you have to feed the mask to define your training area. Okay, so mask is here. And the next you see data augmentation settings. So data augmentation settings is more generally used to increase the number of training samples. So based on your application, you can just adjust this parameters, like you can adjust this things like flip horizontally, flip vertically, whatever parameters you need, you can just adjust that, and then you can use it. So I'm gonna leave as a default values here. Okay, and then you can preview this data augmentation here as well. You can just select the data and then you can just apply, and you can see how the data augmentation applies to your training data. And then use validation. So use validation as by default 20% of your training data goes for validation, and remaining 80% goes for training. If you have any predefined validation data, you can also designate, use this, enable this, and you can load this validation data as well here. Okay, so and the next important feature added here is a visual feedback. Visual feedback in the we are going to visualize the feature like a learning in the training period. Okay, so for that we have to define the region first. So which place are you going to visualize, like which area? Let's say I'm going for let's say I'm in slice number 373 somewhere here, and let me define some region. Okay, so go to annotate here, go to this rectangle, and then just add a rectangle here. Okay, just a small portion of rectangle. Okay, so go here and visual feedback, you can just select that region that you just drew, and there is another tab called training parameters. Okay, in the training parameters, the first one here is the patch size. So patch size, it's like during training, our training data, we split the training into smaller number of patches, so of size like defined here. Let's say here I by default it's 64, so we split the data into 64 by 64 patches, like it defines the size of the patch. And then stride ratio. Stride ratio in the sense like here we have a default value 1, which means like when we split the input data into patches, so there is no overlap between the first patch and the second patch and the subsequent patches. Okay, so if you set the value as 0.5, so which means there will be a 50% overlap. Okay, so and if you keep the value greater than 1, which means there is a gap between our first patch and the second patch, between like data patches. Okay, so that's called stride ratio. And then batch size. Batch size in the sense like the number of patches you're feeding for training at weights. After each epoch it update the weights, so epoch number, and the last function, and optimization algorithm. There are list of optimization algorithms, so I'm gonna set that as a default. Okay, so another important here is estimated memory ratio. So here it's make sure it's green always. So this is like it tells you like, are you within your system capabilities, or if it is red, let's say if I increase my patch size, let's say if I increase my patch size like 256, as you see here, it's the estimated memory ratio, it's highlighted in red, which means the estimated memory requirements exceed my system capabilities. So I'm gonna bring it back to 64, so I'm safe here for training. Okay, and then show advanced settings. In the show advanced settings you have options called uh, callbacks, metrics, and optimization algorithm parameters. You can adjust that based on your requirements. And then for callbacks, early stopping, model checkpoint, reduce learning rate on plateau, terminate on NAN. So I have to also tell you something here before we go for training. What we can also do is we can save the model checkpoints. So by default, if you go to minimize that, and if you go to preferences, there is a place called deep learning. By default, here the enable checkpoint catch is unchecked. So if you want to save and load the checkpoint at each epoch, so make sure you enable this. And again, it depends on the like you can set a maximum catch disk space per model. So if it exceeds, again it based on the allocated space, it saves the model checkpoints. I'm gonna set here 1 GB. Let's see what's happening here. Okay, so this helps you to save the model checkpoint at each epoch, and then you can load that checkpoint later. Okay, and then I'm gonna click OK, and then let's come back here. Okay, so these are the advanced parameters. So we all set, we only have to set inputs and training parameters. We all done here, and then finally we are ready to train. Okay, just click the train button. As you see here, it's steps, it goes through 19 steps, and then for each epoch. So now we are in the third epoch. As you see, your at each epoch you can see the feature here, how it learns. So slowly it starts learning around the seventh epoch. So let's see what's happening here. And on the top, what you see also the model description, and also training parameters information, data augmentation information for this more training, and then training data information, which means like the total number of voxels you have and the total number of voxels used, and how many voxels are mitochondria and their complement, and then complement in the sense like a background pixels, train patch count, how many patches did we use for training, and how many patches for validation. So those counts are here. And then so now the it's running, and if you want you can also give this another. So here we plot this metrics. So we have number of metrics here, loss in the sense like a training, and ORS dice coefficient. Validation loss is the pink one, and the validation ORS coefficient. So these are the metrics we plot here. So this is the epoch, and we are currently in 43rd epoch. Let's wait few more seconds. As you see here, the some places like here it's a thick circles that you see, which means these are the saved checkpoints. So the one that thick black circle, it's the saved checkpoints. And also you see a down pointing triangle here, which means that's the lower value. This one is the lower, and up point triangle here on our validation loss, which is the higher value. Yeah, we are close to finish the epochs. Yeah, it's 98. Okay, so we are done training. As you see here, since you enable the checkpoint catch in the preferences, so you will see the load checkpoint, delete. So here, as you see here, the one that is in thick black, which is the saved checkpoints. So you can just directly go here, and if you want you can just load that checkpoint. Let's say if you want to load this particular checkpoint, you can directly go here and you can load that. But one in this diamond shaped checkpoint, this one is the currently loaded checkpoint, and loaded weight, and which is best by default. Okay, so all the other checkpoints are the saved ones. So if you are satisfied with those weights, you can just load that by using this option. Okay, what I'm going to use here, the default one, okay, which is the currently loaded weight. You can just play with that. And here is just the epoch. It did much better job here. It's we can compare this, okay, later. And you will also see option, you can export this as a movie and the frames per second, and you can just export this. You can export as a image, as a PNG file. So those features are here. Okay, and finally we are going to close this. And if you want to see this again, you go here to back to model overview. If you right click here and if you open model folder in file browser, you here you will see all the checkpoints which are saved. Okay, so those things you can see just by right click the model overview. And if you want to display the training history again, you can come back here and you can display the training history. So those things you can do. You can close this for now. Okay, at the end what I'm going to do is because since I trained this data only for 5 slices, I can apply this data for the entire slices, like 450 slices. Let's say mouse retina training input. I'm going to apply this on all slices. Okay, it takes few minutes. Let's wait and see how the result would be. Okay, so now we apply this. If you want, you can just minimize this. This is the segmentation. I'm gonna hide everything except my mouse retina input. This is my segmentation that I got for all the 450 slices. This is the segmentation output. Actually, it did a pretty job. I have a ground truth also, so I can compare this. So let me compare this. So this segmentation is from my unit output. So let me check if I can get the ground truth. Image and its ground truth. Okay, I have a ground truth here. Okay, so this is my ground truth. We can compare the two data, which means the segmented one from our unit, the trained one with only 5 slices, and the other one is like go to main tab, go to layout. I'm going to use two scene layout. Okay, two scene layout. The first one I'm going to enable is my unit output segmentation unit, mitochondria segmentation, and the next one I'm going to enable is my ground truth. This, yeah. So here this is my ground truth, this is my unit segmentation, and what I'm going to do is there is option called scene view synchronizer. I'm going to use to synchronize the position. So it did like a perfect job. I'm pretty much satisfied with this segmentation. See, this is our ground truth segmentation. This is our ground truth segmentation. This is the segmentation that we received from our unit. It's a nice result. So only if you see here, you see some misclassification, even though the result is not perfect, but it did much better job than other classical image segmentation algorithms.